So for problem number 6, I give us the function y equals the cube root of 2x minus 1. And it says determine the points in which it is the points of continuity and the points of discontinuity of the function. Identify each type of discontinuity. Well, now Mr. Adams has always said the only problems that we have with continuous functions or points of discontinuity is when we have an issue in the domain. What are the two places where we find the issue of domain? 0 in the denominator and even roots. So we're going to expand on that and say even roots. Is this an even root?
Wait, that's for discontinuity?
Yeah.
There's only 3 sections in this chapter.
Yeah. So this discontinuity, in other words, what is the domain of this? Well, the cube root, there's absolutely no restrictions, because you could take the cube root of a negative number. It's only the even roots. Right? Do you guys remember that from Algebra 2?
Yes.
So a cube root doesn't have any points of discontinuity. And so one thing that you could do just to double check that, so in other words, the domain is all real numbers. It goes from infinity to negative infinity, and I suppose you could write it this way too. And so since there's no restrictions on the domain, there shouldn't be any points of discontinuity. Let's check though. Okay, let's just double check. So what I'm going to do is I'm going to graph this. Now we got to remember, how do I enter that into the calculator? Well, this is the same as y is equal to 2x minus 1. What do I raise that to? 1/3. Very good. If I raise that to 1/3, then I'm good to go. So let's plug that in the calculator. 2x minus 1 raised to the, in parentheses, 1 divided by 3. Yes?
Can't you just use the function on your calculator that does that for you?
Yeah, it does have the cube, but there's a reason why Mr. Adams wants to remind you guys of raising it to a fraction. What if this is to the 7th power, or 7th root, or the 6th root? And yeah, there's a thing where you can enter in the y and all that stuff. But at some point in time, if some of you may pursue engineering, you may have 2x minus 1 squared in parentheses, and you'll need to know how to do the fraction stuff, right? Yeah, you could enter it. There's more than one way to enter it in. But we'll do it this way. Hit the graph. Boom, all real domain. Doesn't look like there's any points of discontinuity. Okay, yeah, I can verify that by hitting the trace button and just kind of sliding through everything, just checking everything out. Now there's horizontal isotopes maybe. Maybe not, I don't know. I don't think there would be. But the point is that y is defined at every point that I can think of. So now if I come in and look at the table of values, I could do the same thing. If I scroll up, I don't see any errors in the y values, right? And that's what we're looking for. Are there any errors? No. Right? And I can't think of a reason why there wouldn't be. So it looks like we're good. So points of discontinuity? None. Does that make sense?